In the morning, we have discussed about the damped harmonic oscillator. Damped harmonic oscillator. So in that case, we have formulated certain particular equation that AT is equal to A naught e raised to power minus gamma into T. So in the absence of friction, when there is no friction, that means gamma is equal to 0. So that means the amplitude will be equal to AT is equal to A naught e raised to power minus 0. So that means AT is equal to A naught. The amplitude comes out to be A naught in the absence of friction. And the amplitude decays exponentially with the time. And what time will be equal to? T is equal to, let us say, 1 by tau. At T is equal to 1 by tau, so A is equal to A naught, which is equal to, let us say, 1 by gamma. So when the amplitude becomes 1 by E times initial value is called as a decay constant of the oscillator. So let us say AT is equal to A naught e raised to power minus T upon tau. So that means at T is equal to tau, so AT will be equal to A naught e raised to power minus 1, that is equal to A naught upon E. That means A naught is the initial amplitude, so the final amplitude will be decay 1 by E times the initial value. So when you plot the graph, so this kind of graph which we are going to have is like this way. So this kind of graph is being shown. So that this graph shows that the damped oscillator, the graph of damped oscillator decays exponentially. So that is the first part which has been done in the morning. And that is the conclusion of the damped harmonic oscillator. Now next part is about the logarithmic decrement. Logarithmic decrement. So what happens? The intensity of the damping in case of certain underdamped condition. Underdamped condition is when gamma square is less than equal to omega naught square, is determined by how much the amplitude decreases on the particular complete one oscillation in a time period. That is, the damping is regarded as high or low depending upon the decrease in the amplitude during one oscillation. So that means, let us say, if A1 and A2 are the amplitude at time t1 and t1 plus t. So we will find the ratio. So we will find out A1 upon A2 is equal to e raised to power gamma into tau. That is equal to e raised to power theta, where theta is called as gamma into t. So that is called as, or e raised to power theta is equal to A1 upon A2. So if you take natural log both sides, so it will be theta natural log of E is equal to natural log of A1 upon A2. Natural log of E is 1, so it will be A1 upon A2, where theta is equal to gamma T is called as the logarithmic decrement. So this is called as a logarithmic decrement. So another way in which logarithmic decrement can be defined is, let us say, in the first second it is A naught e raised to minus gamma t1. After n plus 1 second, so it will be equal to A naught e raised to minus gamma t1 plus n time tau. So if you take the ratio n1 plus 1 over A1, it will be e raised to minus n theta, or n theta will be equal to 1. So that means an plus 1 is equal to A1 by E. So this is again the time during which the amplitude decay to 1 by E times the actual value. So that is called as the logarithmic decrement. Case 2, we are going to study what happens during the overdamping. The first condition was underdamping when omega square was less than this one. Now case 2 we are going to take, that is gamma square is greater than mu naught square. In the previous case we have seen that when omega naught square is greater than gamma square, so we have formulated such kind of waves and this kind of equation was being formed. Now for overdamping, we will take omega square is greater than this one, and we know that omega is equal to under root of omega naught square minus gamma square. So which can be written as equal to iota into beta, where beta is equal to under root of gamma square minus omega naught square. So that means it will be in the form of a complex number that is called as iota. So since the omega comes out to be iota beta, so we will write the solution as y is equal to e raised to minus gamma t a1 e raised to minus beta into t plus a2 e raised to minus a2 e raised to beta into t. So that is a general solution of this equation. So that is in case of over damping. So that means e raised to a1 e raised to minus gamma plus beta into t plus a2 e raised to minus gamma minus beta into t. So that is called as this one. So that means if gamma is greater than beta, so that means both the parts will decay exponentially with the time. So again this is called as a non-oscillatory motion. So during over damping means when the friction is very larger than the restoring force, in that case the over damping occurs and the oscillation will be decreased to zero immediately. Now the third and important case, that is called as a case 3, that is what happens during the critical damping. Critical damping. Now critical damping is the damping when critical damping is the damping when gamma square is equal to omega naught square or omega is equal to 0. So that is called as critical, the system is said to be critically damped. So we can write alpha 1 is equal to alpha 2 is equal to iota gamma, or y is equal to a1 plus a2t and e raised to power minus gamma into t. So that means in the initial conditions we can write this form as, now initial conditions are being taken when t is equal to t0, y is equal to y naught and dy by dt will be equal to v naught, that is the initial velocity. So when you put this value over here, so you will get a1 is equal to y naught. So because when we put t is equal to 0, so this part will be 0, this part will be 1, so this will be y naught and this one a1 will become out to be y naught. So we will get similarly we can put the other conditions also. Now second condition is that dy by dt is equal to v naught at t is equal to 0. Since we know that value of v, so we can find the value of dy by dt. So that value we can be able to find is a1. First of all, let us say break up into two parts, e raised to minus gamma into t plus a2 t e raised to minus gamma into t. So these parts will be broken. So dy by dt is equal to a1 into minus gamma e raised to minus gamma into t and plus a2. Now this will be split up into two parts, that will be equal to e raised to minus gamma into t plus t into minus gamma e raised to minus gamma into t. So that is it, this part will be taken. Now when you put the value t is equal to 0, so what you will get? So you will get so when you put t is equal to 0, what you will get? V naught is equal to minus gamma a1 plus a2, or a2 is equal to gamma a1 plus v naught. So that is the value which you are going to get it as. So when you add this both this value, so y will become equal to y naught plus gamma a1 plus v naught into e raised to minus gamma into t. So again this is an exponential term which will be a non-oscillating term. So that means at critical value again it is a non-oscillating value. So so these are the three different conditions in which the damped oscillator used to work it out. Next part will be about the energy loss in damped oscillator. Damped oscillator. How much energy is lost during the damped oscillation? So we are going to drive this equation for it. So we know that energy will be equal to, the average energy loss will be equal to sum of kinetic energy plus potential energy. So whatever the average kinetic energy or potential energy we are going to find out, when you add them, so that means the total energy loss we can able to find it out. So we know that in case of simple harmonic motion, In case of simple harmonic motion, kinetic energy can be found out by half m dy by dt whole square, because it is equal to half m v square. So v is equal to dy by dt whole square. So we will use this expression to solve this value of kinetic energy. So to get this value of kinetic energy, so first we will take the value of y, which is equal to a naught e raised to minus gamma t sine of omega t plus phi. So this is the value of y. So we have to differentiate it out and then solve the value of kinetic energy. So put this value of kinetic energy. So that means y is equal to a naught e raised to minus gamma t sine of omega t plus phi. So we will take the derivative of it. Dy by dt is equal to a naught common. So e raised to minus gamma t will be as it is. It will be into omega cos of omega t plus phi. So this is the particular value which we are going to take it out. Then second derivative will be sine omega t plus phi into minus gamma e raised to minus gamma into t. So that means two variables are there. One is this, another is this one. So by parts will be taken it up. So that means the value of v will be a little bit complicated one. So we can get the value, certain common factor will be taken out. So you will get, it will be equal to minus gamma sine of omega t plus phi plus omega of cos of omega t plus phi. So this value will be come out to be the value for dy by dt. Now this is the value of dy by dt. That is how the velocity comes out to be there. Now we are going to find out the value of kinetic energy. Kinetic energy will be equal to half of m and whole term square will be there. That is a naught e raised to minus gamma t minus gamma sine of omega t plus phi and plus omega and omega cos of omega t plus phi the whole square. So when you solve this square, so you will get the particular value of the kinetic energy. So there are three terms which will be coming out to be there: half m a naught square e raised to minus 2 gamma t, and then you will get three different terms. One is this square, second square plus 2 something. So it will be equal to gamma square sine square omega t plus phi plus omega square cos square omega t plus phi and plus minus 2 gamma sine of omega t plus phi into cos of omega t plus phi. So this is the value which we are going to get it out. So that's why we are going to solve it out. That is the value of kinetic energy which we have taken it out. And then we can find the average value. Average value can be find out by integration of 0 to t 1 by t and kinetic energy into dt. So that means we are going to take the integration of all this value. So we will take the value half m a naught square e raised to minus 2 gamma t, and then the integration is being done for all the three factors. That means sine square omega t plus phi 0 to t, then 0 to t cos square omega t plus phi, then third term is equal to 0 to t sine omega t plus phi into cos omega t plus phi, cos omega t plus phi. So all the three integration we have to solve it out. So once these integration are being solved, their values will be put it out, and then we can able to get the value of average kinetic energy. So that we will discuss in our next lecture.